first off is I had 2 people follow me while I was offline. So, Chiroptical, thank you so much for the follow. I appreciate you. You are appreciated. And Guest House, thank you for the follow. I appreciate you. You are appreciated. So I know I'm starting a little bit late. I had to drive home from the hospital. You know, my wife is in the hospital, so kind of have to deal with that. So yeah, I don't know. Everything's great. Awesome. So I have this guy I'm following on Twitch. He just gave me that's my dog. He just gave me a guest sub. I'm very happy. But his name is Lethargic Waldo, and he has a emoticon of a dabbing Megman EXE. So here's what it looks like. It's pretty awesome. I love it. Waldo, thank you so much. So last episode, what we did was basically read up on how things work. We just read up on one instruction. That's it. Oh, and we also set up the project contents as well into the solution, so it's a bit easier to understand. So I am going to continue down that. So we're still going to do add with binary. So let's open up everything. I know I don't really care about my desktop. I mean, it works and I'm happy with it. I clean stuff off eventually. Alright, so that's going. So one thing I'm actually going to do in the future is I'm going to buy a camera. So I have this camera, right? And I want to buy a second camera that actually look down on a notepad, the notebook that I'm writing on. Because for me, at least, I can figure things out much more easier and work through problems much more better when I can write it down. But because you guys are watching me, I don't want to be boring and seem like I'm just writing on a notepad and you guys not seeing anything. That's no fun. And so and also because I want this to be better for me, and so I learn more as well for me, and also show you guys that there's maybe different ways of learning. So in the future, I am actually going to have a notepad here, and I'm going to have another camera. I just need to know all the stuff I need for that camera, because it's either needs a stand, or needs to be suspended, or something. I have no clue. So yeah, we are going to continue kind of reading up on this. So when we were back to where we were, we found no back. Where the fuck is the back button? There's no back button. That's okay, I'll live. Addressing modes. Oh, EA is DN or next words. Oh, this is a lot of stuff. Okay, so there's many ways to address things. So I'm going to have to go through addressing right now. I think at the moment we're just going to limit ourselves to direct addressing, which is what we will be looking, which is what I'll be doing, because I don't want to worry about kind of worrying about how to address things differently. So addressing direct mode, right? What happens here? In data register direct mode, the effective address field specifies the data register containing the operand. In the address register direct mode, the effective address field specifies the address. Okay, that's fine. Whatever. So we need to go to where we were before, which I don't remember this one. I don't really remember where we were. This seems too far. Where was the ad? I guess I can just search for it, huh? Yeah, I guess I could do that. Oh, you don't do spaces. Oh, I know what to do. Case sensitive. There we go. Aha. Okay. Add. Cool. We found it. Guys, we found it. Oh, yes. I should go. Hold on 1 second. I have my Twitter peeps. Hold on. I need to go to Twitter. I keep forgetting that I have to do this on Twitter. It's like, oh, hey, I'm on here. So I should mention that I'm doing this on Twitter. I guess I could do it on camera, huh? Hey all, come join join me in learning more about the 68K language. Twitch.tv/thatprogrammingguy. Control C, Control V. Let's go on Slack. SLACK. Someone message me? Oh, hey. Oh, yeah, because that programming guy. Yes, because yeah, so I know. Okay, Slack's opening. Has anyone messaged me yet? Nope, no one's messaged me. Wait, hold on. Has anybody? Nope, no one's messaged me. That's cool. So this stream will be a tad bit longer. Because I'm not working this week, so it can be a bit longer, so I'm excited. Control V here. Sweet. Okay, that's going cool. Now I can continue. Let's switch back to Twitch. Sweet. And who is this viewer? Is it a bot or is it not a bot? It doesn't show up. So I have a viewer. I just don't know who it is. Okay, so we have add, right? So basically, I just have to go add either the source to the destination or the destination source, and the emulator has to worry about how to do it. So I need to... I guess I also kind of have to give it a fuckity fuck. A test file. I also, last episode, I talked about a bit of testing as well. Because I will need testing. I just really have no idea how to do it right now. Debug. Let's build everything. Let's rebuild everything. Man, if I keep doing this, I might just have to get an SSD, huh? Okay, so I need a file, right? So I guess I'll put in the solution. I don't know, just fucking assembler. I need a test file that's part of the solution. So can I just add a file? Solution folder. This would be test files? Oh my god, I need to think of a better name for this right now, but test files is what's gonna have to be right now, because that's all I can think of right now. Freddy bot. Wonderful. Okay, why? Come on, little bitch. Okay. Delete you. Rename. No, okay, you're stupid. Delete you. Yes, test files will be removed. Add. New item. Oh, 3 viewers to 1 viewer. All right. Freddy bot is the only person who's with me right now. Text file. We're going to call this test file.asm. I have no fucking clue. Say ASM. There, alright, even added solution items. Okay. This will work right now. If I go to the assembler and I go to program.cs, I look for what? Start program and end program. I guess as well, I don't look for if there's multiple start programs and multiple end programs, so I guess I have to worry about that as well. That's fine right now. Okay, so we have test.asm. Adds the source operand to the destination operand using binary addition and stores the results in the destination location. The size of the operand may be specified as a byte, word, or long. The mode of the instruction indicates which operand is the source and which is the destination, as well as the operand size. So basically, yesterday we just kept reading about add and all of the wonderful stuff you can do with it. All right, instruction fields. Register field specifies any of the 8 data registers. So basically, I would have to go EA or DN, DN plus EA, go to EA, EA, DN. Okay, so the last thing it goes to is considered the destination, right? So this is source plus destination equals destination, source plus destination. I see. Okay, so basically it's reverse. So the valid things I have here, if I go to here, I could do something like add or add with binary, right? Would be, so I could do add, I could have the destination. Oh, what? Hold on, how would I do this? EA plus DN, or I see EA would be the mode and the register. Okay, op mode and register. Okay, so the register field is basically where it needs to go. Effective address field determines the addressing mode. If the location specified is the source operand, all addressing modes can be used. If the location specified is the destination, only memory alternate places are used. The DN mode is used when the destination is the data register. The destination EA mode is invalid for data registers. ADDA is used when the destination is an address. ADDI and ADDQ used when the source. Okay, so source plus destination goes to the destination. I see. So basically, I have to... So I guess the first thing I need to do is like some kind of put. To put a number into a data field. So I guess not add would be what I'm looking for. More of a put, I guess. So some kind of put. do 58 pages. Add binary, add address, add immediate, add quick, add extended, add logical, and immediate to condition code register, and immediate to status, arithmetic shift, branch on condition, test a bit and change, no, test a bit and clear, branch always, test a bit and set, branch to subroutine, test a bit, check register against bounds, clear an operand, compare address, compare immediate, compare memory with memory, test condition, decrement and branch, signed divide and unsigned divide, okay, exclusive OR, logical EOR? EOR, the immediate data with the contour. What's EOR? Oh. to CCR, emulator to status register, exchange registers. Okay. Sign, extend a data register, illegal instruction. The bit pattern of illegal instruction for AFC causes the illegal instruction trap to be taken. As in all exceptions, the contents of the program counter and processor status word are pushed onto the supervisor stack at the start of exception processing. Jump with unconditional. Jump to subroutine. JSR pushes the law. Okay, not going to load effective address. Link and allocate. Logical shift left and right. Copy data from source to destination. Move address. Move to CCR. Copy data from CCR to source. Move from SR. La 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 la. Move multiple registers. Move peripheral data. Is move what I'm looking for? Hold on. Move A. You move copy data from source to destination. Source, move EAE. So move A5 minus A2. What the hell? Move the contents of the source to the destination location. The data is examined as it is moved, and the condition code set accordingly. Note that this is actually a copy command because the source is not affected. The move instruction has the widest range of addressing modes of all 68,000 instructions. Copy data from source to destination. So can I just do like move, here's this literal that I want you to start out with? Does that work? La-di-da-di-da. LMNOLM. Move. Move data from source to destination. Move EA. Moves the data at the source to the destination location and sets the condition codes according to the data. The size of the operand may be specified as a byte, word, or long in condition codes. Instruction format. Size field. Byte, word, or long. Destination, effective address fields. Some effective address fields. Okay, so is there like a put? Because I'm thinking maybe I just use a move to be like, move this literal into this location. That I'm not sure about. Move USP. Copy data to or from USP. Use the stack pointer. Okay, move multiple registers. Move peripheral data. Move quick. Copy a small literal to a destination. Move this. Oh, hey, literal. Move the specified literal to a data register. The literal data is an 8-bit field within the move queue opcode and specifies a signed value from range of -120 to 127. When the source operand is transferred, it is sign extended to 32 bits. Consequently, although only 8 bits are moved, the move queue instruction is a long-run operation. Move queue is used to load small integers into a data register. So move quick. Move peripheral data. I see. So I need to find a literal. Move Q. So move might be what I need. No operation. The no operation instruction NOP performs a no computation. Execution continues with the instruction following the NOP instruction. The processor state is not modified by NOP. NOP can be used to introduce a delay in code. Some programmers use and provide space for patches. 2 or more NOPs can later be replaced by branch or jump instructions. Interesting. Or immediate, or inclusive, or push effective address, reset. Oh, so I got past the pushes. So it looks like move might be what I'm looking for. That's cool. And then also I'm going to have to about like subroutines and how subroutines are going to work. So that'll be fun and interesting. Let's go back to move. So move Q is a literal, which is what I'm looking for. So So I wonder if there's another way to get data in here besides just move Q. I guess set would be another thing to look for. LMNOPQRS. Is there an S? And if this is working, go online to see, like, to just see examples of how to do this. Negate decimal with sign extend. Q elemental P, QORS elemental P, reset, rotate, Roxel, return from exception, return from subroutine. The program counter is pulled from the stack and the previous value of PC is lost. RTS uses terminate the subroutine. Subtract decimals, set according to condition CC. Load status register and stop. Nope. Okay. So subtract binary, subtract address, subtract immediate, subtract quick, subtract extended, swap register halves, test and set operation. What else do we have? We're almost done here. Trap. Trap on overflow, trap on operand, unlink. Okay, so if we go to Chrome, we go to tutorial 1. This for what? Okay, this is for Genesis. This is not what we need. This one, this is also Genesis PHP, which is fine. Not Genesis. Can you just get regular, just regular? All right. Easy 68K. Example. Hey, sample programs. Okay. What is OR? Is ORG in a thing? Find ORG. Okay, sensitive. Next. Previous? No. Okay. Start LEA message A1. Move dot B number 14 DO. Trap simhalt. Message DC.B hello world 0. Org 1000. This tells you some of this program will be located and organized in memory at address 1000. Okay. Start. This is the first instruction of the program. It's also considered subroutine. Think of it as int main. LEA. Message A1. Load the message variable into address register 1. LEA. Oh, hey. Load effective address. Okay. Load effective address. Message into A1. Move.b. Number 14. Move the byte number 14 into data register D0. That's fine. Trap number 15. A hardware interrupt. Think of it as like typing a key. Basically tells the assembler go and display or read input. Simhalt. Terminate the program. Message dc.b. Hello world 0. This is a string variable calling message initialized by dc.b. And at the end has a null terminator 0. End start. Okay. In 60K, a decimal number is specified like so. You have a number 2. I see, so that's just a decimal number. Okay. I see. Move number 14. Okay, so basically just move 14. A hex is hash $. Binary is hash %. State registers. Data register holds the data in the context of this is just numbers. Address register. Okay, interesting. If you run your program, you get screen. In 68K, addressing means how you handle sizes of data. Also means how we work with memory addresses. Notice how hello world is instruction of move.b. Move is the instruction, and .b says that we are going to move a byte of data into the register. Really? Just look at move. Move. I'm assuming the dot notation is something. The dot B is a byte. You know, 8 bits in a byte. W dot and L? Really? So if I go here and just to move, right? Source, move. Move from data to source, move EA, comma EA. Attributes is a size, byte, word, or long. Moves the data at the source of the destination can be set in condition. Codes, the size of the output may be specified as a byte, word, or long condition codes. Oh, yeah, that's fine. Size field specifies the size of the operation moved. A byte is 0, 0, 1, 2, 3, 4. Okay. Destination effective address specifies the... Well, actually, it could be a .b just for the easy 68K, because we are making a different assembler. So, we are making a different assembler, right? So we could just do our own. Destination effective address field specifies the destination location. Only data alternate addressing modes can be used. Source effective addressing field specifies the source operand. Move address. Addressing in 68K also means how we decide to deal with memory and registers. Let's look at move.b. So move a byte, which is 14 to D0. Load effective address. Load address 4000 into A0. Add, move a word, S sub, okay. Printing and reading. I just want to know how to get stuff into. I guess, hold on, because you did a move, right? Oh yeah, move a byte. Okay, so it's literal. So yeah, move is what I'm looking for. Move is the literal. Move the byte 14. Move the byte, which is 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, totally. Move the byte into D0. So move is what we're looking for. I can do this. So if you go to move, copy data from source to destination, EA and E. So if I go to move, EA and EA, attributes, size is the byte, word, or long, which we have here. So we just need, basically we need to specify the size, and we need to specify the destination and the source. So, size field is 0, 0, 1, 2, 3, 0, 1, 2, oh, okay, 0, 1, 2, 3, 1, 2, or 3. Destination effective specifies the destination location, only data, alterable messages. So we need the source, which is here, and then the destination, which goes with here. The source is this, and the destination is there. U separated by commas. I could use spaces if I want to. It's my assembler. I can do what the fuck I want. Destination specifies the destination location. Only data alterable addressing modes can be used. So I see. Source effective address field specifies the source operand. All addressing modes can be used as listed in the following tables. Addressing mode. Okay, I see. So the source. Wide and long. Okay. DN, AN. Okay, so I'm going to have to read more up on addressing so I can see what's what. But we got move, which is so move is what we're looking for. Now I need to get exactly kind of how addressing works in here, because there's a lot of stuff that I need to know about. No. There, conditional testing. No. Floating point conditional tests. Instruction descriptions. The size attribute lines, sections 4, 5, 6, and 7 contain detailed information about each instruction in the M68000. Each section arranges the instructions in alphabetical order by instruction mnemonic and includes descriptions of the instructions notation and format. Figure 3.3 illustrates the format of the instruction description. Note that the illustration is an amalgamation of various parts that make up the instruction description. Instruction descriptions for the integer unit differ slightly from those from the floating point. The size attribute line specifies the size of the operands in the instruction. When an instruction uses operands of more than one size, the mnemonic of the instruction includes suffixes such as B, W, L, S, D, X, and P. The instruction format specifies the bit pattern and fields of the operand and command words and any other words that are always part of the instruction. The effective address extensions are not explicitly illustrated. The extension words, if any, follow immediately after the illustrated portion of the instruction. Name, applicable processors, operand description, instruction assembly syntax, size attribute, text description, applicable results of the floating point operation. Okay. I see. Size is equal to bytes. So basically I can have the dot to be like, okay, the size attribute line specifies the size of the operand. When an instruction uses operand of more than one size, the mnemonic instruction includes suffixes. Okay, I get it. So we do have the dot. This is one thing I missed. I'm glad I looked at the instructions. So how the fuck does addressing work? Do you have? I don't think you have how addressing works. You just have the instruction. Okay. Direct, indirect, address register indicating with post incrementing or pre-decrementing, address register indicated with displacement, and address register indicated with indexing and displacement, absolute addressing with a 16-bit or 32-bit. I see. Wide is 16, long is 32. Program counter or relative addressing, and immediate value, which may be 16 or 32 bits depending on the instruction. IMM. Okay. IMM is immediate. Okay, so if we go back to move, bastard. Move. The source. Addressing modes. Pound data. Let's search up this, shall we? Control C, find V. No, AV. Next. Bastard. go all the way up here. There's a lot here. Wait, no. Oh, this is, oh, I see, this is floating point. Okay. Did I just freaking see a floating tangent? Oh, that's crazy. Okay. May 24, 25, 26, 27, 28. Thank you. That shift and rotate, that's fine. Okay, so I need to get back to addressing. So IMM is immediate. So actually, if I go here, right? Add, right? Add. Addressing modes. I can just use hash the data, which is 111. So I don't even need a move. I can just add these. Right? Yeah, I think so. I can try it. We can see how this goes. I mean, the worst comes to worst, it just won't work. Which is fine. If the location specified as a source operand, all addressing modes can be used. IMM. An immediate value literal, which may be 16 or 32 bits, depending on the instruction. Okay, so... Load effective address, move 9 digits to add. Clear X bit and Z bit of CCR. Loop, add a pair of digits, repeat until 9 digits added. So I have loops as well that I have to worry about in here, which I will worry about later when I get to loops. Add binary. Byte, a word or long word. Add the source operation to the destination operation. Store the results in the destination location. DN, AN, IMM. So I guess, what if I do IMM? Immediate? Adds the immediate data to the destination operand and stores the result in the destination location. The size of the operand may be specified as byte, word, or long. The size of the immediate data matches the operand size. Adds an immediate value of 1 to 8 to the operand. Okay. Interesting. All right. So does immediate mean a literal? Can you just show me all of it? Is that a bad idea? Ho! What did you do? Go away. So is immediate like hash? What is the hash for anyway? It says byte, but where in this manual does it actually say that? Yeah, so if I data or I can just do this, because I'm a dumbass. A bit number is specified as the immediate data or the contents of a data register. So I think hash data is what I'm looking for. Because I think that's what it is. I just want to find like something in here that says this is what it is. It's really annoying because I've done, I've had to do this a lot of stuff before where it's like, oh yeah, you have to kind of find what this is. I mean, keep pressing next is not going to be a good way to figure this out. Alright, let's just go up here. Addressing modes. Integer, unit, user programming. Program which adds 3 numbers together and subtracts another one. Lock 1. Whoa, what? What's lock 1, lock 2, lock 3? Result EQ 2006 answer location org starts at 1000 main program move a wide number from location 1 to D0 add wide location 2 to 0 add wide location 3 to 0 subtract wide pound $1F 0 to D0 move D0 to result stop end. I get it. So it's an x68 extension. Oh shit, you know that. Huh. Maybe it's because I installed Easy68K. So lock 1 EQU location 1. So there's constants in here. And then we have another constant called result, which is equal to pound 2006, which is basically like, I think, a comment, which is the answer location. So we have the $. And the main program, move 2000 into DQ, add, stop. Okay. So we have the $, which is a thing. But I get it. What is the $, in here? This said what the $, was, didn't you? Organize. That's the... Oh, I see. Okay. So this is the location 1 is at point 2000, 2002, 2004. The result will be held in 2006. About 1000. Move location 1 into D0. I see. So this doesn't say how to get the numbers in there, but that's a good start. First, definitions using code. First bytes value equals 2000. First location, number of locations to be changed. Value to be written to memory. Start of the code location. Move a dot so long. This is referring to the comment, to the constant, to A0. Move wide the number of bytes. D0. Next. Okay, so this isn't an instruction address, is it? Yeah, so this isn't an instruction address. So there's other stuff here that I'm missing. Cues? Okay. Guys, I have to go to the bathroom quickly because I drank a fuck ton of water. I'll be right back. Let's mute myself, shall we? I don't think you want to hear this. All right. So I guess as well, what did you say? Hear my dog shaking in the background. Okay, go Joe. I guess technically this is my own assembler, so I can write what I want. But I do know when I actually get to the Sega Genesis, right? I'm gonna have to know everything. So I will have to know it. It's just cues. The user. Oh. The user can implement queues, groups of information waiting to be processed with an address register indirect with post-increment and pre-decrement addressing modes. Using a pair of address registers, the user implements a key that fills either from high memory to low or low to high. Two registers are used because the queues get pushed from one end and pulled from the other. One address register contains the put pointer and the other the get pointer to implement growth of the queue from low to okay. So what is this next? Oh, are you labeling it? Oh, I see. You're just labeling it. Loop back if not finished. B and E. Okay, B to next. Oh, okay. B and E. Find B and E. God damn it. B and E. Branch on condition. Really? BCLR, BRA, yeah. LMNOPQRS, alright. Branch on condition. BCC. BEQ and BVC? Branch on condition CC. Oh, it's not capitalized. Okay, so B, what the fuck? B and E. Branch on not equals. Yes, calendar, thank you. If the specified logical condition is met, program execution continues at location PC plus displacement D. The displacement is the 2's complement value. The value in the PCU corresponds to branch. The assembly language from BCC plus minus plus 8 multiplication plus 8 means branch to the point 8 bytes from the current PC if the carry bit is clear. Okay, I see. This is branching. Okay. Branch not equal to next. And next is basically move the value to A0. Write the value to the current memory location. Increment the memory pointer. Decrement the counter. Loop back if not finished, otherwise stop. Bytes is to D0. Okay, interesting. So this supports labels, I'm guessing. Find LABEL. Label? Label. Assembly program label. Okay. BCC, FVCC, and condition is true. Okay, so I can add labels to this. If a label such as add appears in the table, it indicates the FPU performance. I like BCC label. Oh, it needs a label. Okay, I get it. So it's like I'm learning so much. EQU. What's EQU? Shall we? EQU. Next. ORG and EQU, right? Okay. $99. Oh man. Guys, the requirement is 8 megabytes of RAM and 2 megabytes of hard drive space. Guy, I don't think we can do this. I don't know. I don't know, man. Year 2000 compliance software. No way. No way. Recently, there's been concern about the impact of the upcoming millennium changes when the year 2000 arrives. The concern is that systems which store the year's teachers will no longer function properly. The 68,000 editor does not use the date. Oh my god! No way! No way! The 68,000 editor does not use the date for any internal or external purposes. Therefore, the editor should not have any problem with the year 2000 or beyond. To make sure all versions of 68,000 editor since version 4.0 have been extensively tested and they are deemed to be fully compliant with year 2000 date range. No way! Oh my god, this is so cool! The fact that they're like, yeah! Guys, there's a message board! That I can't write to. That's so cool. Oh my god. Assembler and simulator. Echo. Really? How long is this? Trimstat TRM data equals that. Terminal status registers. Okay, so I need to like... God, can you just tell me the freaking syntax? Like, there's labels. Okay. Because really, why they just use EQU? Oh my god, EQUALS equals. No. 70. Okay, so what about ORD? ORD? God damn it. ORD. Order? No, no, no. Damn it. 1, 2, 3. ORD. Okay. So... for a number or register as a source, the A destination or memory location. Not every instruction has this kind of syntax. Load effective address. Add, move, sub. Instructions that don't have a similar kind of syntax. Printing and reading I/O. Move values between registers. Move A. Moves addresses between addresses. This is used to move things to the stack pointer. Load a value doing math. Yeah. You can write a macro that will greatly simplify the way you do things. Oh, macros! Oh my god, macros. Okay, control. Macro. You suck. You can write a macro that will greatly simplify the way you do things. For example, here's how to print macro. Here's how a print macro looks like. Opt mex. Op code EQU 0. Text EQU 1. Section text org section org. Print the string. Print macro. Oh, macro. Why macros? Oh, is easy 68K just like is EQ from 68K like features. GUI assembler with color syntax. Edit multiple files, structured assembly, if for while repeat dbloop, dbloop, conditional assembly macros, mini assembler directives, DCEQ. Oh, an assembly directive. Can I search for directive? Directives. Condition if it specifies the coprocessor condition we tested. This field is passed the MC6885 one, which provides directives to the main processor. Oh, so is all of this just like fancy stuff? Let's zoom in here. A, B, C, D, E. Exit, e.g. There's no equals here. Okay. So is just like the EQ like type count address data checksum? No. The LEA command stands for load effective address. Move B stands for move a byte. Move a word. Move a long. Number 14 means the literal number 14. Trap 15 does a simulator input or output. Because, I mean, it's my assembler, so I can write what I want to. Message is a label. Start org 1000 code for output. LEA message A1. Message dc.beak. So can I write labels in the 68K? Message is a label dc.b. Reserves memory for the item following it. Message dc.b. A byte. Hello world. Place the ASCII string into memory at message. Oh, right, because this is like a C style string. Okay. Okay. Oh, control and line feed. Output of the code from above. Notice the text. The fourth line. Now you... Alright, so now that the simple tutorial is done, you should be able to write anything. Move a byte. 0 trap 15 end start. Start and end. Okay. So can I do labels in here in the 68K? Start or because this is saying the 68K assembler and simulator. Editor and front end assembler and simulator. Lets you write and test assembly language for the Motorola 68K processor. The program is designed and lets you edit assemble 68K programs. If you would like to download the program, then why not visit our download page? Also, if you find this program useful, please make sure you register the editor. Registration is free to educated establishments. Why not have a look at some sample programs that you can test using the editor? Just click on the samples page. If you would like to be emailed when a new update is out, ListBot, need extra help? Why not ask a fellow 60? Post on the message board. Guys, we have a message board that doesn't work anymore. XRMX.com. Add menu. Because, yeah, it's like first EQU is 2000. So, because it's saying it's an assembler directive. can also set variables and constants above your code like so. Address 1 EQ that. So it's the labels. Okay. Condition codes, that's fine. Memory, macros. You can write in macros that greatly simplify the way you do things, because here's how a print macro looks like. Print, which is a macro, section text, halt, macro, move.b, trap, and message, program start, print, end line. So you can write subroutines for n60k. Think of them as like methods. A subroutine must be first be defined by a label, do stuff, colon, do more stuff. How to implement the loop in 60k? A while loop, control and checking, doing math. So now I'm like, what are these label things? You know, because basically EQU. What if I do this? What if I just do like da 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 la li la li la. EQU. Right? EQU. Okay. So what is EQU? Like, is EQU a label? Is there something, is there processor instructions that I'm missing because I'm not used to it? Right, guys? Instruction format, effective addressing modes. Program counter, no. Immediate data. In this addressing mode, the operand is in one or two extension words. Table 2.3 lists the location of the operand within the instruction word format. The immediate data format is as follows. Generation operand given. Assembler syntax is pound XXX. EA mode fields is 111 and the register field is 100. Number of extension words 1, 2, 4, or 6. Byte word, long word, high order word of the operand is the first extension word. Packed decimal real. Effective addressing mode summary. Okay. Oh my god. Alright, so yeah, so I found that. That's cool. Effective addressing modes. Effective addressing mode summary. Brief extension word format. Full extension addressing modes. Other data structures. System stack and queues. Instruction set. Program control instructions. Is a label. Yeah, but where is the EQ thing? Like, is that... Because the EQ thing is like, is that a 68,000 thing? This section describes the instruction provided for the CPU32. The CPU32 can execute object code and many instructions. There are 3 new instructions provided to CPU32: enter background mode, low power stop, and table lookup and interpolate. Okay. No, this isn't what I'm looking for. Instruction format summary. So constants, I guess, would be what I'm looking for. Constant. No memory indirect action mode uses BR, extend with its modifiers, and BD to calculate the address. Data register indirect app. Oh! Rosnovsky. Thank you for the follow. That actually really surprised me because I didn't even... Oh my god, I didn't even notice that. I'm glad it worked. I have no idea how it looked, though. From what I've seen on my Active Fireball channel, the sound is, I think, is ahead of the image, but that's fine. Thanks for the follow. How are you today? No memory, no, I don't register index with constant index. I might have to look for constants. 10, 11, 12, 13, 14, 15, 16, la da da da, la 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 la. No, that, no. Move constant ROM. Okay, constants. Yes. And consists of at least one word. Some have as many as 11 words. Figure 2.1 illustrates the general composition of instruction. The first word of the instruction, called the simple effective address and operation word, specifies the length. The effective addressing mode and the operations to be performed. The remaining words, called brief. What sentence? These words can be floating point, command words, conditional, predicates, immediate operands, extensions, the effective unpack constants, or argument counts. Oh my god. An instruction specifies the function to be performed with an operation code and defines the location of every operand. Instructions specify an operand location by register specification. The instructions register field holds register number. I mean, technically, I could do my own constants, but I want to make sure, like, I just want to make sure, because I do know when I go back to Sega Genesis programming, it's not going to be how I want it. Well, no, I could actually do what I want with constants. I could. I don't know why I'm reading so much, because remember, this is my assembly. I can do what the fuck I want. Something's in my eye. You know, although I sometimes miss contacts, I'm really glad I never have to deal with the burning pain that happens when you get something in your eye when you have contacts. Why does it hurt so much? Does anybody know why it hurts so much when you get shit in your eye when you have contacts? Because that fucking hurts. Again, so if I make a Sega Genesis thing, I can make my own assembler. I'm just gonna make my own assembler, right, guys? Okay, so fuck doing all this. Like, reading this helped a lot. I'm glad I did. That's cool. Constants or argument counts. Single effective address operation word. One word specifies operation modes. If any, 1 or 2 words. If any. So if we go to easy 68K, features, mini assembler directives. For a long time, we meet assembler directives are instructions that direct the assembler to do something. Directives do many things. Some tell the assembler to set aside space, assigns a value to a symbol, equals org, sets the current origin to a new value. This is used to Set the programming register in assembly. For example, org that tells the assembler to assemble all subsequent code. Defines the amount of free space no code is generated. Okay. Tech tools. 68000 processor directives. In any assembler, symbols may be defined in two ways. By using the symbol as a label, it stands for the address into which the following code or data will be placed. By defining a symbol and giving it value directly. In 68K, use symbol equals value. In Spark, use symbols equals value. For example, array size is equal to 10. The array is... Okay. Standard library routines. To call a routine, use JSR name, stop, new line. Okay. So... directives. Oh yeah, this field is past the coprocessor, which provides directives to the main processor for processing this instruction. Set coprocessor on condition 789. Go back to 1. Branch on coprocessor condition. Specify the coprocessor. So again, what kind of assembly directives does the 68K have? Right? Because I don't want to mess up. I don't want to use something that's not... I guess, again, I'm making my own assembler, so I could, again, do whatever the hell I want. But I still want to get kind of close to actually 68K programming, because that's what I'm doing. But I can also go off the beaten path and do what I want as well, assuming my eye doesn't keep fucking with me. So again, what is all of it? What's Spark C, by the way? Reference manual. Tools, easy 68K. Addressing indirect. Register direct mode. That's not what I want. Again, I can do whatever I want at the moment. Addressing modes. Do you have directives? Right, start org 1000. So this has org 1000. So there's some common knowledge. There's some common knowledge that I'm missing here. And there's some common knowledge that I'm missing. This is in Spanish. Physics. Okay. Registers a status register, data organized in memory, data addressing modes for instructions. I guess I would have to get more into knowing about how the memory works, wouldn't I? Data addressing modes for instructions. Instruction set summary A, B, C, D, E. So this also doesn't have EQ. So it's not an instruction. So what is the thing I need to search for? Assembler directives. The assembly language contains mnemonic directives that specify auxiliary action to be performed by the assembler. Directives aren't always translated to machine language. Assembler directives assist the program in controlling the assembler's output and defining data in symbols and in allocating storage. The assembler translates... Okay, so... You didn't tell me anything I wanted to know, bastard. Okay, 3.1 and 3.2? Did I just not find it because I'm starting to get tired? Yeah. This isn't a double operand operation. Operand tested sign trap equivalent to format. Stop operand if condition. Test the condition. If true, the operand after then is performed. Okay. Register specifications. Positive infinity. Beat specified sign for double precision. Negative F. Immediate data following the instruction or words. It depends on indirect. Address and register in memory. Base displacement. Scale size. CCR. La la la. Da 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 da. Assembly program label. Assembly control org. Org qualifier expression comments. The org directive changes the program counter to the value specified by the expression in its operand field. Subsequent statements are assigned. Okay. Qualifier may be either S or L. Relocatable program selection. Section. End. End directive indicates to the assembler that the source is finished. So end is what I'm looking for. Offset. The offset directive is used to know, okay. Page list, no list, format, no format space, no page, it in, nops, opt, fail. Linkage editor control. Okay. So are these directives just like common knowledge that I don't know about because this is my first time doing this? If we go to Dev Talk, which fucking no one's on right now. Start and offset. Assembly for mask 2 include a secondary file. Symbol definition. Symbol definition directives EQ, reg, and set provide the only method by which a symbol appearing in the label field may be assigned a value. Other than that, corresponding current location counter. Label EQ expression. EQ directive assigns the value of the expression in the operand field to the symbol. The label and expression follow the rules in given chapter 2. The label and operand fields. Okay, label set expression. So chapter 2. What's chapter 2? What is this for? M68000 family. Reference manual. The image log system carefully checked and is believed to be entirely reliable. However, no responsibility is assumed for inaccuracies. Furthermore, Motorola reserves the right to make changes to any products herein to remove, improve, reload. Okay. Copyright 1983, 6th edition, June 1983. Scope, introduction. Directives. So did I just download the wrong thing? The assembly language changes mnemonic directives with specified auxiliary action performed by the assembler. Okay. Are instructions to the assembler program, non-instructions to the Oh, assembler program. Oh, I get it. Guys, I get it now. It just took me fucking like 40 minutes to figure it out. Assembler directives, not microprocessor instructions. Okay. I get it. I understand now. Alright. Assembler directives. So because these are assembler directives, I can do what the fuck I want. Only took an hour and 21 minutes. Fuck. Anyway. That took forever. So we have assembler directives. And then we have, okay. Valid. So this thing is for an assembler. So this is the whole entire thing for the assembler. Okay. Of common ones. Okay. I get this. I'm getting this now. Okay. I get it. Just origin relocated to a program section, program N, define offset assembly for mask 2, and include secondary files. Symbol definition, EQ, equate symbol value, set symbol value, define register list. Data definition, storage allocation, define constant. Listing, page, top of page, listing, lists the assembly, do not list assembly, format, no object, assembler output options, fail, program generated error, linkage, editor, invoking the assembler, command line format, okay. Alright, so these are all the ones I need to worry about. Okay, I get it. I get it. God, this took me for easy 68K. Oh, these are the assemblers for easy 68K. Cool. So now that we did that, let's go back to add, shall we? Add. Add source to destination or destination to source. So the destination can either be a direct address or this. And a byte word long. So we add byte, add word, add long. Cool. Add register view specifies any of the data registers. Effective addressing determines the addressing mode. I see. So EA can be some data. So if the location specified is the source, then you can't use that. Okay. Cool. So if I want to add the source, which would be EA, right? Register in mode, op mode, register. Op mode fields are here. Register field specifies any of the data registers. This one, effective address field, determines the effective addressing mode. If the addressing mode is data, then the mode is 111 and the register is 100. if the location specified is the destination, only memory alterable addressing modes can be used. Okay, so we're just going to worry about this right now. We're just going to worry about add, give a literal number to a destination. So I'm just going to do start and end. Right? Add. Source, which is going to be a number. So we want to add right now just a byte. And we want to say a byte is number 1. So 1 to destination 0. Boom, done. First line of assembler. Cool, wonderful. All right, everyone, that is, I don't know, should I continue? Because the assembler is going to take this and change it. I don't know, I think that's it. All right, everyone, thank you so much for joining me. For the follows, thank you for the follows. For the people who did view me and then left because I was just reading shit, sorry. So what we got done today was a lot of reading. I think the main thing was that there's assembler directives and then the instructions. And the assembler directives can change depending on what assembler is using, but there is common assemblers as well. We also had a laugh that the website was Y2K compliant. And we wrote a first line of assembly. So the next step will be to, I guess, maybe echo it, but have the assembler read it and understand it and then echo it. Anyway, that is it for today. I might stream again later in the week. We will see. And this is mostly just because I have the week off. Anyway, I love you all. And remember, you can do the thing.